Welcome to Right Tuition Classes, children. We are doing ICC Physics Chapter 2, Part C, Conservation of Energy. Okay, children? Now look here. Actually, energy exists in various forms. Okay, energy exists in various forms in our universe. Various forms. Okay, in our universe. Various forms in universe. This is not a note or anything. Just I'm writing here so that you remember. Okay, what I'm saying. See, energy occurs in various forms in the universe. Various forms. But and now what I do, I find some of all the energy, sum of all the energies. Okay. And suppose I get it as x joules, I get it. Sum of all the energies, all energies of the universe when I do it. Okay. I get it as, please have a look at x joules. Got it? Now, energy transformation takes place. Transformation takes place, energy gets transformed from one form to another. Okay. And now, after this transformation, again, when I see sum of all energies in the universe, sum of all energies in the universe, okay, universe, again, when I look at it, again, what I see, x joules. That means the conversion takes place from one form to other, but the sum total always remains the same. Got it? That means energy remains conserved. Energy remains conserved. Okay. This is what is, please, our energy remains conserved. Matlab, energy is not lost at all. Okay. Even the transformations takes place. So this is called law of conservation of energy. So remember, what is principle of law of conservation of energy? Just what I have written here. Please here try to understand once again. I'll tell you, energy exists in various forms in the universe. So when I do the sum of all energies of the universe, say I get x joules. Now energy transformation takes place. Matlab, energy transformation takes place. Matlab, energy gets converted from one form to another. After that, again, when I try to find the sum of all the energies in the universe, again I get x joules. That means while the transformation is happening, but no energy is getting lost. The energy remains the same. That means, can I say energy remains conserved? So this helps you to write the principle of law of conservation of energy. So what is principle of law of conservation of energy? Principle of law of conservation of energy. Remember, okay, the same thing. From here, I can tell energy can neither be created, energy can neither be created, energy can neither be created nor destroyed, okay? But okay, the energy can neither be created nor destroyed. It gets transformed. Energy can neither be created nor destroyed. Okay, it only changes from one form to another. And one more point I'll write: the sum total of energy, energy in the universe remains constant. Okay, it's constant. So this whole thing is called law of conservation of energy, principle of law of conservation of energy. So remember, beta, What is principle of law of conservation of energy? Energy can neither be created nor destroyed. It only changes from one form to another. The sum total of energy in the universe remains constant. Okay. So in the same way, I'll put it one example and see, okay, what I'm trying to tell you. This was in general I was talking about. Let me try to tell you with respect to only mechanical energy. See, when you see mechanical energies, or a mechanical energy of a body is nothing but mechanical energy of a body is nothing but is mechanical energy of body is nothing but sum total of kinetic energy and potential energy of the body. Got it? Now, mechanical energy of a body is nothing but sum total of kinetic and potential energy of the body. Remember this, okay? That means, please have a look here. Suppose in a mechanical energy transformation takes place in this mechanical energy. Kinetic energy is getting transformed to potential energy. Got it? But the total mechanical energy will always remain conserved, will remain the same. Whether potential is getting converted to kinetic or kinetic is getting converted to potential. But the sum total of this energy will be always equal to that mechanical energy. But one condition should be there, provided we don't consider the force of friction. There is no force of friction. Then only this can come true. Otherwise, this doesn't. Okay. So remember, children, okay, we assume one thing, the force of friction is negligible while telling this. Correct? The mechanical, the sum total of kinetic and potential energy of a body is the mechanical energy of the body. Okay. So here what I want to tell you is throughout the motion of a body, I want to tell you the total mechanical energy will be kinetic energy plus potential energy remains constant. Okay. So this is what we are going to verify. We are going to verify this. Okay. So remember one very important topic we're going to do, children. So the important thing, theoretical verification of K plus U equal constant. K for kinetic energy plus U for potential energy equal constant for a freely falling body. They can ask you in an exam, okay? So I'll say let a body of mass m, let a body of mass m, let a body of mass m fall freely, fall freely, let a body of mass m fall freely from a height, h above the ground from position A. Okay, so this is bodies here, beta. So this is your height h, beta. Okay, so let a body of mass m fall freely from height h above the ground from position A. Okay, that means the body is going to fall freely from point A. Got it? Now remember one thing. As the body falls freely from A, this potential energy of the body keeps on decreasing. लेकिन क्या हो रहा है डिक्रीजिंग हो रहा है पोटेंशियल एनर्जी घूम जा रहा है क्या नहीं potential energy keeps on decreasing but its kinetic energy goes on increasing. Got it? Kinetic energy goes on increasing. So throughout the motion, if we see, the sum total of kinetic energy and potential energy will be equal to the energy what it had, potential energy what it had at A. See, at A, please have a look here, it has a energy called potential energy. Got it? So at every point during the motion, the sum total of potential and kinetic energy, even though it is getting transformed, potential is getting transformed to kinetic, but the sum total of potential and kinetic energy will be equal to the potential energy what the body had at A. And this is what I'm going to show you. K plus U is constant for a freely falling body. So we say, let a body of mass fall freely from height h above the ground from position A. Got it? And it reaches. Please have a look here. B is in B is a position. B is a position in its path. At a distance of x from A, and C be the position on the ground. C be the position on the ground. So I said, beta, please have a look here. Now, I just mentioned all the three. This is x, okay? This distance is x. It has followed, okay? So suppose at position A, when you look at it, beta, at position A, the body is actually at rest. That means kinetic energy है ही नहीं, क्योंकि kinetic energy कभी होगा when the body is in motion. So kinetic energy है ही नहीं, so k equals 0. And what will be U, potential energy? Mass into acceleration into height, acceleration into mgh. So what is total energy at A will be equal to k plus u, 0 plus mgh. How much you get? Equal mgh. So remember, total energy at A is mgh. Got it? Now at position A. So at position A, you came to know the total energy. Mechanical energy is mgh. Okay. Now the body falls at position B. Now let's say at position B, it is falling down. So I'm considering this position B. At position B, AB distance fallen down equal x. Therefore, height of the body above ground at B equal, shall I do h minus x? H is the total distance and it has fallen a distance x from top. So naturally at B, what is the height of the body above the ground at B? H minus x. So what is potential energy here? Potential energy equal m into g into height. And what is the height? H minus x. So this is nothing but mgh minus mgx. Mg gets multiplied with h, mg gets multiplied with x. So this is it. Potential energy is so much. mgh minus mgx. Please see it, okay? They are different, mgh and mgx. But you know, beta, at BV, it also has got kinetic energy. It's falling. इधर रुकता नहीं है बी में पोजीशन लिया लेकिन वो कंटिन्यू मूव हो रहा है मतलब बी में भी उसका एक वेलोसिटी है तो अगर काइनेटिक एनर्जी if I want to calculate I should know the velocity of it. So what I do, see here, therefore there is no time involved. I told you when no time is not involved, remember third equation of motion, v square equal u square plus 2as. Okay, so let's see here. I want v square equal. U was 0 because at A, the initial velocity is 0 plus 2 into A is g, okay, acceleration due to gravity. But what is this height? What distance it has covered? Oh, it has traveled the distance x. So I'll take x. So what is v square equal to gx? V square equal to gx. Am I right, children? V square is 2gx. Therefore, kinetic energy at B equal half into mv squared. So when I do half into m, and what is v squared? 2gx. So what gets cancelled? 2 gets cancelled. mgx. So what is kinetic energy at B? mgx. Therefore, total energy at B equal, what it will be, beta? Potential energy plus kinetic energy. You have to add both of them. So potential energy was mgh minus mgx plus kinetic energy. How much you got? Oh, mgx. So how much you get? Total energy mgh minus mgx plus mgx. Oh, mgx gets cancelled. You're getting mgh, total energy at B, mgh. So please have a look here. Total energy at A was 1. Okay, total energy at B is 2. Okay, now what I do? The body continuously falls. The body keeps falling and reaches position C. Position C. So now at position C, what has happened, better? At position C, the height from the ground has become 0. It is at height is 0. That means the potential energy becomes 0. Potential energy is 0. But kinetic energy is half mv square. I would like to find. So you see here, v square equal u square plus 2as. V square, what is the final velocity? V square. U square is 0 plus 2g. And it has traveled a distance h now. Therefore, v square equal to gh. Now, kinetic energy is half mv square equal half into m into 2gh. How much you get? Children, 2 gets cancelled. You get mgh. So this is kinetic energy. Potential energy is 0. So what is total energy at C, children? Therefore, total energy at C equal total energy at C equal 0 plus mgh. How much you get? Mgh. What is C, children? And this I call it as 3. So I go from 1 to n3. What I see, the total energy during the motion remains the same, mgh. Got it? So I know while during free fall, the potential energy went on getting reduced, okay, and it was getting converted into kinetic energy. But the sum total of energy at any point in the position was always equal to the potential energy of the body on top. Okay, it was always equal to the potential energy of the body on top. Correct. And even as it falls to the position C, got it? That time, even though the potential energy is 0, but kinetic energy is equal to mgh. That is, it is equal to this energy what it had on top. That means throughout the motion, the energy of the body remains the free fall. Throughout this free fall motion, the total energy of the body will remain conserved. Correct? The total mechanical energy remains constant. But only on one condition. We have assumed there is no force of friction. If force of friction would have been there, then here some energy would have got spent in overcoming the force of friction. So the total energy what you get at C will not be equal to that energy what is at A. Got it? Got it? But we are going to consider the force of friction is 0. So energy at C is equal to the energy at A. I hope everybody gets me here. So I'll just write last part of it. I'm going to rub the starting part. Shall I write here, children? Therefore, we see, therefore from 1 to n3, got it? We see, 1 minute, children. I'll rub it off and then continue writing. Therefore, from 1, 2, and 3, 1, 2, and 3, we see the total energy during the motion, total mechanical energy during the motion, total mechanical energy during the motion remains same at every point in that every point in the motion, at every point during the motion, at every point during the motion. Correct? Hence, mechanical energy of a freely falling body is conserved provided we consider provided we consider the force of friction to be zero. Be, be zero. Okay, children. I just proved it. Okay, theoretically, we verified that at every point, okay, for a freely falling body, the sum total of energy at every point in its motion remains the same. Only thing is, while freely falling, the potential energy is going on reducing and it's getting converted into kinetic energy. But the sum total of energy remains the same. It is always equal to the potential energy on top. Or even I can say the kinetic energy the instant it touches the ground is equal to the potential energy of the body on top. The same thing is true. The moment we throw a body up with a hand, okay, so the energy, maximum energy we have imparted to the body. Now that energy is actually the kinetic energy. So as the body is traveling up, the kinetic energy keeps on reducing, but keeps on reducing. It's not getting lost. It is getting converted into potential energy. It's going on gaining potential energy. At maximum height, the total kinetic energy becomes zero, but it has maximum potential energy, and that potential energy is equal to the kinetic energy at the with the what it was thrown, with what it was thrown. That potential energy on top will always be equal to the kinetic energy with what it was thrown. Are you getting me? Okay. So the sum total of the energy will always remain the same. Okay, children. So this I just said about mechanical energy, law of conservation of mechanical energy. One small thing, this graphical representation of law of conservation of mechanical energy, for either you call it as downward or upward motion, any one motion you consider, okay? Now, what I'm taking is, let me take a free fall body, downward motion I'm taking, okay? So what happens is, this line, when you look at it, kinetic energy I've written, and I've written here potential energy. These lines represent, you see, at point A, the maximum height is h, this is height, मतलब maximum height is h, and maximum height में potential energy mgh है, ये potential energy है, that means ये line देखो, potential energy का है, potential energy कितना है, mgh है, got it? और kinetic energy कितना है बेटा, kinetic energy बोलिए तो कौन सा line आएगा बेटा, kinetic energy ये आएगा, देखो kinetic energy at maximum height is zero, ये energy, kinetic energy is zero, this is mgh, this is zero, so ये दोनों में इधर कितना है, potential energy कितना था बेटा, mgh, काइनेटिक एनर्जी कितना है, जीरो, दोनों को ऐड किया तो टोटल एनर्जी कितना है, mgh. Got it? अच्छा, at point B is nothing but a height h by 2. Got it? So when I look at it, ये पोटेंशियल एनर्जी का लाइन है, पोटेंशियल एनर्जी इधर आ गया बेटा, इधर क्या है, mgh upon 2. ये काइनेटिक एनर्जी का लाइन, अरे इधर क्या है, काइनेटिक एनर्जी भी mgh upon 2 है, तो टोटल एनर्जी mgh upon 2 plus mgh upon 2, mgh. Okay. At point C on the ground, height above the ground is zero. So kinetic energy, ये line kinetic energy क्या है? तो kinetic energy at point 0 में kinetic energy किधर है? इधर mgh है, correct? And this potential energy कितने में है? 0 में है. तो potential energy 0, तो total energy mgh plus 0 mgh. So again, graphically we see the total energy during the motion always remains the same. It's conserved. That is, mechanical energy is conserve. But again, I'll tell you, provided the force of friction is zero. If force of friction will exist, children, then the total energy will not be look conserved, okay? Where some energy will get used up in overcoming the forces of friction, okay, children? So I just showed you here graphically. Remember, this line is potential energy, this line is kinetic energy for a freely falling body. Got it? So I just graphically, I showed you all, okay? Anyhow, children, we go to the last part, okay? That is, I want to show you, I want to just discuss application of principle of conservation of energy to a simple pendulum, okay, children? This last part of this chapter, and then it will be, this chapter will get over. Right, we'll just see conservation of energy, okay, in a simple pendulum, in the motion of a simple pendulum, in the to and fro motion of a simple pendulum. Suppose A is the initial position of the pendulum at rest. Hence we call it as a mean position. Now this pendulum is taken to, now this pendulum is displaced or is taken to position B, which is at a height h, which is at a height h above its mean position, okay? So, and please have a look. Suppose A is the initial position of the pendulum at rest, hence we call it as a mean position of this pendulum. This pendulum is taken to position B, which is at a height h above its mean position, and left freely. Okay, so due to gravitational force, the pendulum moves along the path B to A to C. Moves along the path B, A, C, and again from C, it moves along CAB, and thus it keeps doing to and fro motion. Thus it keeps doing to and fro motion. Remember, A is the, listen children, A is the initial position of the pendulum at rest. Hence, we call it as a mean position. Now, this pendulum is taken to a position B, above position B, which is at a height h above its mean position, and left freely. So due to gravitational force, the pendulum moves along the path B, A, and C. And again from C, it moves along C, A, and B. And thus it gives doing to and fro motion. Now at B, at B, at position B, okay, potential energy is equal to mgh. Kinetic energy will be equal to 0. Suppose mass of the pendulum is m. Suppose mass of pendulum to be m. Okay. Now at position B, P is mgh, K is 0. So total energy will be PE plus A, K mgh plus 0 equal mgh. Okay. Now at position A, okay, H is 0, potential energy will become 0. And what is kinetic energy? Kinetic energy will be equal to half mv square. But v square equal u square plus 2gh equal 0 plus 2gh. So v square equal 2gh. Therefore, Ke will be half into m into 2gh equal mgh. So total energy at A, total energy equal P plus K. 0 plus mgh. How much you get? Mgh. At position C, again P will be mgh, K will be 0. So total energy equal PE plus KE mgh plus 0 mgh. Thus we see, even in the motion of pendulum, the total energy, throughout its motion remains constant. Remains same. I can say remains constant or remains same. Okay, remains constant. So again, please remember, from A as it is going again, from A to B, the kinetic energy keeps on decreasing, potential energy keeps on increasing. At B, it has maximum potential energy, 0 kinetic energy. So it's at a rest. It's at a rest for a fraction of a second. Then again, due to gravitational force of attraction, it starts falling back, moving. So now the potential energy is decreasing and it has maximum kinetic energy at A. And the potential energy becomes 0 because the height is 0 almost. Again, as it starts climbing upwards towards C, its kinetic energy keeps on decreasing and the potential energy keeps on increasing. Again at C, it has total potential energy, kinetic energy is 0. So throughout this to and fro motion, you will see the total motion energy of this pendulum remains the same. Mechanical energy remains the same. Got it, children? So with this chapter gets over.